All right, good morning, everyone. Going to get you to get yourself organized here, put your phones away, get all of your work out, including the work from last week, dealing with the laws of logarithms, your unit handout, all that stuff. Welcome back. The laws of logarithms are given to you there. Hopefully between the lesson on Friday and the work you've done since then, they're becoming ingrained in you. You know what to do when you see certain things. That the logarithm of a product is the sum of the logarithms. The logarithm of a quotient is the difference of the logarithms. The logarithm of a power is the same thing as the exponent on that power times the logarithm of the base. And if you ever need to, you can use a change of base formula, although that doesn't really play too big of a role in the assigned problem. So first of all, my mistake that when you take a look at number 11, when you look at C and E, you do not know how to do those, because there's a type of logarithm called a natural logarithm, which is ln. So I will just talk about that briefly here. You know that there's this thing called a common logarithm, which is just written this way, and it's presumed that you understand when you just see log without a base, it's base 10. That's something you are expected to know. So this is actually, I got my m there, this is actually log base 10 of x. Well, this is called a natural logarithm, and it's pronounced ln, like mowing your lawn, ln of x, and it is actually what's called a base e logarithm. And if you're interested in what e is, it's the second function of your divided by symbol. You do not need to know this, but some of you might be interested. It's equal to that number. That number looks suspiciously like it's a rational number because it looks like 2.7, 1828, 1828. Like it looks like that 1828 is repeating. It's not. Okay? It's an irrational number. It's, if you take calculus with me, it's the type of logarithm that we will use most frequently because it makes our job easier. So you don't have to worry about C or E. All that being said, does anybody have questions you would like me to go over? Go ahead, Jay. 5B. 5B? So we're asked to put this together. Well, it says write it as a single logarithm. The conversation that I had with you and a few other people this morning needs repeating, though. You will not, on an exam, most likely be asked, what is this thing as a single expression? What you will be asked is, this is equal to what? A, B, C, D. Or if it's numerical response, then it might be, encoded with letters that you have to find the values of. But basically, you're just looking at this and saying, how can I simplify it? Something's a little bit cut off here. Is that 1/3? It is, okay. So before you can bring logarithms together, you need to go through a couple of little checklists. One of them is that all of the logarithms have to have the same base, and the other is all of the logarithms need to have coefficients of 1. So when you pack logarithms together, you want to bring the coefficients up as exponents, but if you wanted to break a single logarithm apart, you're going to use the product and quotient rules and then move the exponents down. I'm getting log base A, and a big part of this unit in getting answers from this point is going to be to use your exponent rules, but I'm getting p to the 1/3. I'm getting q to the 3, And I'm also getting over p to the 4. And it doesn't serve any purpose for me to write the p to the third as the cube root of p, because I notice there's a p in the numerator of the argument and a p in the denominator. I might as well simplify them. And I need to have a little discussion with everybody about this rule that we have of taking a base and subtracting the exponents on that base when you divide. And the conversation that needs to be had is that this, whatever you get, will be over 1. Okay? So, for example, if I had x to the 6 over x to the 11, and I go 6 minus 11, I get negative 5. That means it's x to the negative 5 over 1. And then I can move that to the bottom. Some people get confused about that. I mean, here you might just say I'm going to cancel x to the 6 from top and the bottom and be left with x to the 5 on the bottom. But, you know, what cancels here is a little bit more obscure. So what I'm going to do now is say to myself that this is going to be the base A logarithm of p to the third minus 4 multiplied by q cubed. And now I need to figure out, that's a minus sign, what a third minus 4 is. You can use a common denominator, or you can use your calculator, but I believe you're going to get 11 thirds, and it will be negative 11 thirds. So I end up with log base A of p to the negative 11 thirds times q cubed. We've got this kind of unwritten rule in math. Negative exponents are a little bit verboten. We don't want to use negative exponents. So I'm going to move that p to the negative 11 thirds to the bottom of the argument and get log base A of q cubed over p to the 11 thirds. What you could have done, and I don't know if this occurred to anybody, but logarithms are interesting this way, is going back up here, we could have taken 1/3 of this log p and subtracted 4 of that log p. You know, if I have a third r minus 4r, I get negative 11 thirds r. So you could have said 3 log base A of q minus 11 thirds log base A of p. Move that 11 thirds to the top. It's a negative logarithm, so that p to the 11 thirds will end up on the bottom. There are other ways you could have done it, and in retrospect, that might have been simpler. I don't know. But that's okay. Other questions? Yeah, go ahead.
11b.
Okay. It's a very complicated question to wrap your head around. Okay? Can I ask you a question though, Craig? You're asking about B. Were you able to reason out what the answer to A and the answer to D were?
No.
Okay. A?
No.
Okay.
No, I don't.
Okay. So I want to talk about A and then D, and then we'll get to B. This is log base 5 in A. Log base 5 of 5 to the 7. And once again, I prefer that set of brackets around the argument if the argument is a power. So what this is saying is, to what do I raise the blue 5 to get what I've highlighted in yellow? It's saying, to what do I raise 5 to get 5 to the 7? Well, 7. Right? I need to raise this blue 5 to the number 7 so that I get 5 to the 7. Don't forget, this is the meaning of a logarithm. Log base 3 of 81 is 4 because 4 is the exponent to which you raise 3 to get 81. Okay. So then that's A. What about D? Well, D is saying, to what do I raise this c to get this entire c to the t? And the answer is t. Unfortunately, this is different. B is really different. So let me write it out for us. It is 10 to the log of 6, which is base 10. So it's 10 raised to the base 10 logarithm of 6. Now this that I'm going to show you will help us a little bit later today. What we could do is we could say, well, I'm going to call this A for my answer. And I'm going to take the base 10 logarithm of both sides. Why, you ask? Because it's going to help us. So I've simply introduced the base 10 logarithm of both sides of this. I have taken the base 10 logarithm of the left side equals the base 10 logarithm of the right side. But now what is this equal to? This gets very confusing. What is that equal to? It's the exponent to which you raise 10 to get 10 to the log base 10 of 6, which is log base 10 of 6. To what do I raise 10 to get what's in here? Well, I need to raise 10 to this exponent. Well, that must mean A is 6. All right? But a couple of observations are in order. One, you didn't have to reason it out that way. You could have said that I'm going to take this exponent and write it in front. Right? I'm just using the power law. But log base 10 of 10 is 1 because you raise 10 to the 1 to get 10. So you're still left with the same statement. However, for Jay and anybody else who were here this morning in Sabre Sport, I finished with this explanation, and then I started off with the one I'm going to give you now. I hope everybody would agree these are inverses. And they're inverses. I don't want to talk about graphs. They're inverses because one undoes the other. Provided you start off with a number that's not negative and not 0. I just want to stay away from those. If you take any number in the universe and you square root it, other than 0 or negatives, you square root it, and then you take that number and you square it, you're back to where you started. Okay, so if I take the square root of 5 and get 2 point whatever, when I square it, I get 5. These are inverses. They undo each other. These two things undo each other. Now, there's limitations on this because you need to be dealing with quadrant 1, but take an angle in quadrant 1, take the sine of it, and then immediately go inverse sine. You'll be back at that angle. Well, these, y equals 10 to the x and y equals log base 10 of x, are inverses of each other. That's why when you look at your calculator, you'll see where the log button is, the second function of log is 10 to the x. So, for example, if I take the log of 7 and then I go 10 raised to that, I get 7. If I take 10 raised to the 7, if I take 10 raised to the 7 and take the log of that, I get 7. So I can do them in any order. The bottom line here is that 10 raised to and log base 10 of cancel each other. This is equal to 6. And you can arrive at that by just understanding that inverse operations undo each other. And that's another way to explain why log base 5 of 5 to the 7 is going to give you 7. Because base 5 logging and 5 raised 2ing are opposite operations. They undo each other. And the order that they happen in doesn't matter. I hope that's helped, Craig. Okay, other questions? Yep.
16.
Okay, let's take a look at number 16. So what is this equal to? This is why I think brackets are important with logarithms. This thing that we are asked about really has a set of brackets here, right? But the point I want to make is that argument is 2x, and it's not the 2x that is being squared, it's the whole logarithm. We don't have to write the green brackets, okay? We don't. But when you look at your rule for when you can move the exponent down, you move the exponent down in front. I'm talking about the power rule here. You move this exponent down in front if it's an exponent on the argument of the logarithm, but not on the logarithm. So, that being said here, we can't do this. It's a very tempting thing to go, oh, I'm going to move that exponent down in front because that's how logs work. No, because that exponent is not on the argument. It's the whole thing. So what can we do here? Well, you can take log of 2 plus log of x. That's the only real rule that we can apply here because it's log of 2 times x, and this is squared. Well, what does a binomial squared mean? It means log of 2, in this case, plus log of x, multiplied by log of 2 plus log of x. And by the way, these are all, not that I don't think it matters, but they're all base 10 logarithms. So we FOIL this out, and what we get is log of 2 times log of 2, and you get log of 2 quantity squared. It's very similar to me writing sine of x times sine of x. You get that, right? You can't multiply the x's. And by the way, somebody somewhere has said, let's do that. A few years ago, I kind of got around a movement that I would like to get the whole world to change and adopt this. I didn't start a movement, but I wish it was that. I wish that's how we wrote the square of a logarithm. Because then it would be in alignment with trigonometry, and it would make more sense rather than thinking of all of these brackets. Anyway, we don't do that. I think if you wrote that on a diploma exam, they would go, yeah, okay, I get it. My outer will be log of 2 times log of x. And there's no, once again, there is no, I'm going to get all this stuff out of the way right now. There is no rule for multiplying logarithms. There's a rule for a logarithm of a product, but there's not a rule for a product of logs. And by the way, do you see that that's my outer, but my inner will be the same thing, so I have 2 of them? You can see where we're going with this, right? And my last will be log of x times log of x, which is log of x quantity squared. And that's it. Other questions? Go ahead. 15? So you got all this parsley sprinkled on the fish here. X is greater than 0, y is greater than 0, and z is equal to x cubed y. The reason why x and y have to be greater than 0 is because they're going to appear as arguments in a logarithm, and you can't take the log of a negative or of 0. So what is log of y equal to? Well, my thinking is I'm simply going to introduce logarithms here by taking the base 10 logarithm of both sides. Because then I have a way of extracting a log of y. There's another way to look at it, and in retrospect I wish I would have started with it, but that's okay. This becomes log of z equals 3 log x plus log y. Are you okay with that? That means log of y is equal to log of z minus 3 log of x. And now I'm swinging back and forth the other way. I don't know that the other method is any easier. What we could have done is taken this and solved for y first. And then taking the log of both sides. But you're going to get log of z over minus 3 log of x. Does that do it for you? Okay, other questions?